So we are discussing about intersection of planes. Okay, so this is the cube. So this is the cube and it is intersected by this plane. And what we have to draw is this intersection. Alright, and the intersection plane. That is what we have to get the projection for. Alright, that is what we have to do. So what we do is, first of all, we draw the top view of the cube. That is what we do. Okay, so that is what we do. Draw the top view of the cube. Then what we do is we draw the intersection plane. We draw the intersection plane. Okay, so this intersection plane is what we draw. So here, now here you have to keep in mind the intersection plane has to be drawn in this manner: dash dot, and the intersection part, the part where the plane intersects with the solid, that part is dash dot dash. Okay, and that part you have to keep in mind, it has to be lighter shade. Okay, lighter shade than what is outside. So this is the outside plane, outside portion of the plane which is intersecting with the cube, and this is the intersection part. Alright, so this is the intersection part here, and it has to be lighter shade, and you can see this is dash dot dash and this is dash dot dash. Okay, so that you have to keep in mind. So first you draw the top view, then the plane of intersection. So once that is obtained, what we have to do is we have to project it upwards. So first of all we have to draw the cube. This is the cube. Okay, then we have to, so this is the point of intersection, we project it upwards, and this is the line. Okay, so this is the point of projection, so we project it upwards, and this is the projection plane. Okay, similarly this is the point of intersection here, and we project it upwards and we get this intersection plane over here. So this is the point and we project it upwards and we get the intersection plane. So this is the intersection plane. It has to be shown like this in a shaded manner. Okay, now this DH edge, the edge DH will be hidden. Okay, the edge DH will be hidden, and therefore you can see it is in dashed line. Okay, this is the axis, so dash dot dash line, this is the axis. Okay, and this is the outer edge over here, FH is the outer edge. Okay, FH is the outer edge, so that you have to show as a straight line over here. Okay, and this is the surface of intersection. This is the surface of intersection. So that is what we have to do. Okay, so it is not very tough. Only thing is that you have to, I mean, just as we did in the things in the projection of solid, simply it is like that. And thing is that there will be a plane which will be intersecting, and we have to just find out what are the points of intersection, and then we have to project it to the front view. So this is the front view. This is the front view, and this is the top view. So top view, in case of top view, you will see only this surface, only this surface and this intersection line over here. Okay, of this plane. This is the plane, so this is intersection line. So this is what you are seeing here. Okay. Now one thing you keep in mind, in the exam I have noticed that many of you have drawn this kind of drawing. Okay, so in the exam you need not draw this. This is just a concept drawing, so that you can build up the concept. Okay, this is the solution. So this is the top view and this is the front view. So only this is what you have to draw in the exam. Alright, whether it be point or line or whatever, the projection is what is required. Okay, the projection. So this is the projection on the horizontal plane. So this is the projection on the horizontal plane, and this is the projection here, the intersection line. Okay, this is the intersection line, and then it is projected to the vertical plane, and this is what we have observed in the vertical plane. So the front view and the top view is what we require. Okay, so that is you have to keep in mind. So this is the intersection of solid. So this is a triangular prism base 30 mm side. So a triangular prism base 30 mm side and axis 50 mm. So axis is 50 mm. Okay, it is lying. So triangular prism in this manner. Okay, it is lying on the HP on one of its rectangular face. So the rectangular face, it is lying on the HP. So on the HP it is lying. Like this it is lying. And it is cut by a horizontal section plane. So it is cut by a horizontal section plane. The plane is horizontal. Okay, so obviously the cut section will also be horizontal at a distance 12 mm above the ground. Okay, so this is 12 mm above the ground. Draw its front view. So, and it is inclined at 30° to the VP. Okay, so it is inclined at 30° to the VP. So this is the concept. Okay, so we have the prism. So the triangular prism is there. It is lying on one of its rectangular face on the horizontal plane. Okay, and it is cut by a horizontal section plane. So the section plane is horizontal. Okay, and this is the section which is cut here. This is the section which is cut here. So now what we have to do is, so it is 12 mm above the ground. Okay, and we have to draw its front view. So this is obviously the front view, and we have to draw the sectional top view. Okay, so the top view we have to draw. So what we do, we start with the prism face, the face of the prism. Okay, so that prism face is used to get the height of the prism. Alright, because 30 mm base is given, so we draw 30 mm base. Okay, and this is 30 mm and this is 30 mm. We get the height of the prism. Then we draw the prism. Okay, so what we do is we draw the prism here, inclined at 30°. Okay, we draw the prism first. This is the second step. So this is the prism, the top view of the prism. Okay, first let us forget that there is a plane. Okay, so we inclined at a 30°. So if you see the prism, so we have this length of the prism which is 50 mm given, axis is 50 mm, and the base is 30 mm. It is already given, and at the center we have the edge here, this edge over here at the right of the center. Okay, so we draw this prism over here. So once we draw this, we project the projectors up. Okay, then we get the front view of the prism now, only the prism. Okay, only the prism. So only the prism, that is only the prism, we get the front view. Okay, so then once that is done, now what we do is we draw the intersection plane here. So at a distance of 12 mm. So this is 12 mm. Okay, at a distance of 12 mm. So now what we do, we get this point 1, 2 and 4, 3, 4. We get the points 1, 2 and 3, 4, and we now project it below here. Okay, now we get the points 4, 3, 2, 1. So that means we get these points, and we can draw the plane of intersection here. Okay, so what is step 1? Step 1 is to draw the prism here, prism face here. This is the step 1. Step 2 is to draw the top view of the prism, inclined at an angle of 30 degree. It is given here. So one of its rectangular faces is lying on the HP, and its axis is inclined at 30 degree. So the axis is inclined at 30 degree. Okay, so you draw the rectangular face which is lying on the HP. So the rectangular face which is lying on the HP, and you draw this upper edge over here. Okay, and this edge. Now once this is done, so step 1 and step 2. Then from here, so from B and C we project up to get B dash. From C we get C dash, and from A we get A dash. Okay, so from here we have to project this, and from D we get D dash. Then we draw this front view of the prism. We draw the front view of the prism. Once the front view is done, then we draw the intersection plane. Okay, so intersection plane is what we draw, the intersection plane. So we draw the intersection plane. And we get the points 1, 2, 3 and 4. After getting the points 1, 2 and 3, 4, so we again project downwards now. 1 we project to 1 dash, we project to 1, 2 dash we project to 2, 3 dash we project to 3, 4 dash we project to 4, and we join this 1, 2, 3 and 4. So this is the plane of intersection we get. Okay, so those are the steps. So we studied about this cube. Now we have a plane. So here the plane was parallel to the VP. Okay, so plane was parallel to the VP and it was perpendicular to the HP. Plane was parallel to the VP, so vertical plane, and it was perpendicular to the HP. Now we have a plane here. We have a plane here which is inclined at some angle to the VP, and it is perpendicular to the HP. It is perpendicular to the HP. Okay, so a cube is in the same position as in the above this problem. Okay, it is cut by a section plane inclined at 60 degree. Alright, so 60 degree it is given to the VP and the perpendicular to the HP, so that the face which makes 60 degree angle with the VP is cut into two equal halves. So basically this line or this face of the cube, it is divided into two halves. So one half and two half through this plane intersecting through this point. Okay, draw the sectional front view. So sectional front view, this is the front view, top view and true shape of the section, that also we will see. It is unlikely that but still we will also see what is the shape of the section. Okay, so what we have to do is front view, top view. So first we will start with the cube. So we draw the top view of the cube. First step, number 1, top view of the cube. So top view of the cube. Then number 2, what we do is we draw the plane, intersecting plane. It is inclined at 60 degrees, so equal to 60 degree we draw the plane. Okay, and dividing it into two halves. So this length is equal to this length. So that we have to keep in mind. And we draw this line. Okay, so this is we draw the intersection plane in the top view. Okay, so first step, second step. So then what we do, we project it upwards. Okay, so we project it upwards. So first of all, we project it up and we draw the cube. So this line will be hidden. This line will be hidden, dotted line. So DH is this one, this edge. So it will be dotted line. FB will be here, FB. Okay, and then we project this plane. So 3, 2, it will be projected up. So 3 and this will be 2 dash. And similarly 4 and 1 we project up, and this is 4 dash and this will be 1 dash. Okay, and this is the plane of intersection. So this is the plane of intersection. Okay, so that is what we have to draw. That is what we have to draw. Okay, so AE is projected up here, E dash and A dash. So E dash and A and E. Okay, similarly we have GC projected up, and similarly we have 4, 4, 1, 1, 4 dash and 1 dash. Okay, so and 3 and 2 here. So 3 dash and 2 dash. So we have this front view of the intersection plane. So that is what we get. So the steps are given here easily. So first we start with the top view. Then we draw the intersection plane. Then we project the projectors up. Okay, and then we get the cube, the front view of the cube first, and then we draw the front view of the plane, intersecting plane. Okay, now in case it is asked for the true shape of the section, so this is the true shape. Alright, so true shape means what you see right from the front of the plane. If you see right directly from the front of the plane, normal to the plane, alright, so you get the true shape. So here obviously this is the length, this is equal to this length, so we can directly project here perpendicular here. Okay, and this height is equal to the height of the cube, so this height is equal to the height of the cube. Okay, and we get the true shape of the plane. This is the true shape of the plane. But when you see from the front, you will see the projection here, and this being projected here, so you will see like this, it is tilted. Okay, so this is the front view projection of the plane, this one. Okay, so now here it was inclined to the vertical plane and it was perpendicular to the horizontal plane. So in this case it is perpendicular to the vertical plane and is inclined to the horizontal plane. Okay, and this is the true shape. This is the true shape of the intersection plane. Okay, so again what we do, first step is again we draw the top view only. We draw the top view. So we draw the top view. So we draw this top view. Now in this case, the plane is parallel to the VP. So when you see from this edge, so you will see the edge like this. Okay, so what we do after drawing the cube, After drawing the cube, you first project the projectors for the cube, the points of the cube. Okay, and you draw the cube first. So this is the second step. So this is FB, okay, and this is DH, which is hidden here, so dotted. Okay, so then you draw the cube. So first the top view of the cube, then the front view of the cube, projecting up. Then you draw this plane of intersection. So this plane of intersection at the given angle. Okay, at the given angle. So now we have here the points of intersection. So we have the points of intersection here. So we have this 1 dash. Okay, this is 1 dash. Then we have this 4 dash. Okay, so this is 4 dash. Then we have this 2 and 3. It will be along the same line. Okay, so 2 dash and 3 dash will be hidden here. So 3 dash you will see from the front, and 2 dash will be hidden behind 3 dash. Okay, so 1 dash, this is 1, so this is 1 dash, this is 4 dash, so this is 4 dash here. Okay, so I have drawn this line over here. So 4 dash is basically the intersection between the DH and the plane of intersection here, and 2 and 3, it will be on the top face of the cube, and 2 will be hidden behind 3. Sorry, 3 will be hidden behind 2. So here 2 is outside, so 2, this is 2 and this is 3. Okay, so then after we get these points, after getting those points, we again, now from these points we draw the projectors down. So we have got the 3 point, so this is 3 point we have got. Now we also need to get the 2 point. Okay, so from this point, that is 2 dash 3 dash, we have projected the projector vertically down, so we get the 3 point and 2 point. Then, so this is 4 over here, so we get this 4. So from here we drop it down, we get this 4. Okay, then from here, so from here we drop it down here. So from here we drop it down, and we get this top view of the plane. So this is the top view of the intersection plane. Okay, and this is the true shape of the intersection plane. That is the true shape. Okay, but thing is that this is the requirement. So here again, the first step is the cube, top view of the cube. Second step is draw projectors from the points of the cube and draw the front view of the cube. Third step is draw the intersection plane. Fourth step is identify the points and draw projectors below. And then you join the points to get the plane for the top view, intersection plane for the top view. Okay. So again, while drawing, you have to keep in mind you need to draw only this one. So while drawing, this is the plane of intersection. So outside, whatever you will draw, that is in deep, you can see the line is of darker shade, alright, and dash dot dash, and the inside one is dash dot dot dash. Okay, and it is of lighter shade. Okay, a square prism, 40 mm side, axis 80 mm long, has its base on the HP, and its face is equally inclined to the VP. Okay, faces equally inclined to the VP. It is cut by a perpendicular plane perpendicular to the VP, inclined at 60 degree to the HP. Okay, so first of all, Again, so square prism. So first of all we draw the top view, alright, or the square prism, and then we get the prism standing up. Okay, now it is given as its face equally inclined to the VP. Okay, so the faces are equally inclined. So these faces, so here you see the faces are equally inclined to the VP. So this is the VP. So that means here we can consider this. This is the HP and this is the VP, and the prism, square prism, is standing like this in front of the VP. Okay. So top view you will see is like this, and the front view, when you will see, you project it up. Okay, so you will see these two edges being projected. Okay, and this edge being projected here. So these two edges you will see, and this edge you will see like this, and this edge will be hidden behind this edge. Okay, so you will see this one. Then it is cut by plane perpendicular to the VP. Okay, plane is perpendicular to the VP, inclined at 60 degrees. So the plane is inclined in this manner. Okay, and it is cutting the prism. Okay, so first again we start with the top view. So top view of the prism, square prism. Second is we project it up and we get the front view. We get the front view. Now third is we draw the plane inclined. Okay, 60 degree. So 60 degree plane. Okay, and then again we have to now project this below. So here we will project it, and this we will project it. Yeah, somebody please check your mic. Someone is using your mic and it is creating a sound here. And we have this intersection here. Okay, this is the intersection. So if you see from the top, what you will see is the plane, it is intersecting here, and obviously it is intersecting here. Okay, so this plane, it will be of this manner. So this is the plane, intersecting plane. Okay, so this is the intersecting plane over here. So here what you do, so first is the top view. Okay, first is the top view first. Second is the front view. Third step is to draw the plane of intersection. From the plane of intersection you drop projections. So this is 4 dash and this will be 2 dash. Okay, and this will be 3 dash here, and this will be the plane of intersection, like this. Okay, so this is the plane of intersection. So it is of this manner. Okay, it is of this manner. So here 1 and 5 dash is here, 1 and 5 dash. Okay, so 5 to 2 dash, 5 to 2 dash, or 1 to 2 dash, basically 1 to 2 dash is this edge, 1 to 2 dash, and 5 to 4 dash will be hidden behind. 5 to 4 dash will be hidden behind. Okay, and 2 dash to 3 dash will be this one, this edge, and similarly 4 dash to 3 dash will be this edge. Okay, now when you see this plane from the top, so you will see 1 5 dash here, 1 5 dash here, so 4 dash is here, 2 dash is here, and 3 dash is here. Okay, and you have to mark this plane like this. So this is the plane of intersection. Okay, so this is the plane of intersection. So this is the solution. So this is what you have to draw in the drawing sheet, in the exam or in the assignment or whatever. So this is what we require. So this is the front view and this is the top view. This. Okay. So this is just for understanding the concept. Okay. So we have the steps. Okay. So this step first, second, third, fourth, and obviously fourth is the final one. So then you have to mark the plane here. So hexagonal prism has a face on the HP, has a face on the HP. So it is basically lying down. Okay, and the axis parallel to the VP. Axis is parallel to the VP. So it is lying down and is cut by a sectional plane, the HT of which makes an angle 45 degree with the XY. So basically it is the plane, it is making an angle of 45 degree with the horizontal plane. Okay, so it is making an angle of 45 degree with the horizontal plane. So horizontal, so if suppose we have this plane, so if the trace is making an angle of 45 degree with the XY, if it is making a 45 degree with the XY, so this is the trace. Alright, so this is the trace here, which cuts the axis at 20 mm from one of its end. Draw the sectional view and true shape of the section. True shape it is afterwards. So base, side base is 25 mm. Alright, so this is 25 mm and the height is 65 mm. So we start with again the top view. Alright, so top view, project it up, you get the front view. Okay, sorry. So front top view, project it up, you get the front view. Considering the prism to stand in front of the planes. So it is standing in front of the planes. Like this. Okay. So then what you do is, so it is written here, has a face on the HP. Alright, so we have to put it in a sleeping position. Alright, so this is also the top view. So this is the top view over here, and when you will rotate it, you will get the front view. Okay, and this is the plane of intersection. So this is the plane of intersection. So what we do is, so first we draw the hexagonal prism standing upright. Okay, so this is the front view. So front view, rotate it down. Alright, it is in the sleeping position. So it, as soon as you rotate it down, so it will be sleeping on the HP, as a face on the HP. So this face DC will lie on the HP. So this is the step 2. So step 1, step 2, and this is step 3. Okay, after step 3, so we have to project the points. Alright, the main, I mean the hexagonal prism points. Alright, the prism points you plot and you get the top view of the prism. So this is the top view of the prism. Once the top view of the prism is obtained, so then you draw the section plane. Once the section plane is drawn, again you get these points. So these are the points of intersection. So these points again you have to project up now. Okay, so once you get these points, you then obtain the plane of intersection. So this is the plane of intersection. So that is what is required to be drawn. Okay, so this is the front view and this is the top view. Okay, and this is the true section of the, or true view or true section of the section plane over here. Okay, so if you see straight from this face like this, so you will see this plane like this, right? So if you see from the front, this is what you are going to observe, right? This is the projection, but in most cases this will be asked, so this is what you need to draw, right? Front view and top view. In some cases it may be asked, so you have to draw that also. So we have a pentagonal pyramid now. So base is 30 mm, side and axis is 65 mm long and has its base horizontal and edge has its base horizontal, alright, and an edge of the base parallel to the VP. A horizontal section plane cuts it at a distance of 25 mm above the base. Draw its front view and sectional top view. Alright, so this is the prism. So pentagonal pyramid, sorry, not prism, pentagonal pyramid. So we have the pyramid here standing in front of the VP, and this is the plane of intersection. So thing is that when you see from the front, you will obviously see this is the front view and this is the plane of intersection. This is the plane of intersection. But when you see from the top, so you will see the front view, top view of the pyramid being projected here like this. The pentagonal face here, base, the pentagonal base of the pyramid here like this. Then apart from that, you will see the section. So this is the section which you will see from the top. So from the top. So what to do? So first of all, we again, first step, number one step is to draw the pyramid top view. Okay, so an edge of the base parallel to the VP. Edge of the base parallel to the VP. Okay, so that is how we draw the top view. Once the top view is drawn, you project up and it is given, it is 65 mm long. So this is 65 mm long. So this is the point O, you project it up at the 65 mm long and you join these points. Okay, so first of all, top view of the pyramid. Second is front view of the pyramid. Third step is you draw this plane of intersection. Draw the plane of intersection. That is the third step. Okay, so once you draw the plane of intersection, again from the plane of intersection, now these points you have 1, 2, 1, 5, 2, 4, 3. Okay, so 5 will be projected here, 5 dash will be projected here. So 5 dash will be projected here, 4 dash will be projected here. Similarly 3 dash will be projected here, 1 dash will be projected here, okay, and 2 dash will be projected here. So you join these points and you get the top view of the section plane. Okay, so top view of the base, number 1 step. Number 2 step, project it up, get the front view of the pyramid. Number 3 step, draw the intersection line. Number 4 step, project the points to the plane of intersection here. So here in this manner. Okay, and ultimately you get this plane of intersection. So this is the solution. Okay, this is the solution. So that is what is required to be drawn. This one. Okay, this one. This is just the concept. So a square pyramid, base 40 mm side and axis 65 mm long. So base 40 mm side. So square pyramid, base 40 mm side. So 40 mm side. And axis is 65 mm long. So axis is 65 mm long. So this length is 65 mm. Okay, 65 mm. Has its base on the HP. Has its base on the HP. So base is on the HP. And all the edges of the base are equally inclined. Again, it is equally inclined. So the base is like this. So this is the base, and if this is the length, so we have the pyramid like this standing in front of the HP. Okay, and this cut by a section plane perpendicular to the VP. So plane is perpendicular to the VP and inclined at 45 degree to the HP, bisecting the axis. Okay, axis, it is axis bisecting. I mean, it is dividing the axis into two. So that you have to again note, bisecting the axis. So first step is draw the top view. Draw the top view. First step. So this top view you draw. First step. Then you project it up. Okay, so 65 mm long, and you draw the pyramid. Okay, so this is the second step. Third step is, okay, here sectional side view is also given. So sectional side view, so you draw the side view as well. So either you can use the 45 degree angle projectors, or you can also use the arc, taking this as the center. So you can use also the arc, whatever way. Alright, and this O is projected up, and this is the side view. Right, this is the side view. So first you draw the pyramid. Whatever drawing has to be done for the pyramid, you draw. Then it is cut by a section plane perpendicular to the VP and inclined at 45 degree. So if you see in the front view, it will be inclined at 45 degree. Okay, so here it will be inclined at 45 degree, and is bisecting the axis into two. So this axis, it has to be bisected into two. Okay, so this part and this part has to be equal. So bisecting the axis at two. So at this point, at 45 degree, we have to draw the plane, intersecting plane. Okay, so this is the intersecting plane. So once the intersecting plane is drawn, so now what you do, you first find out the points of intersection. This point, this point. Okay, so 1 point, 2 points. Here there will be 2 points, 2 dash, 4 dash, and 3 point. Then you project it down. So this is 1 point. So 2 dash, 4 dash will be projected here like this. Okay. And then we have the 3 point here. Okay, similarly 2 dash, 3 dash is projected here to this point. So 2 dash and 4 dash is projected here like this, 2 dash and 4 dash, and 1 dash is projected here up to this point. So we have, if we observe from this side, this plane, we will see this intersection plane over here. This is the intersection plane. If we see from this side, if we see from the front, so it will be in this manner. Okay, this is the intersection plane. So ultimately we have this plane. Okay, sorry. Uh, we have to also consider the inclination of the this this edge. Okay, so this inclination we have to consider. So to obtain that, what you can do is you can project this downwards, and then from there you can project it in this manner, and then from there you can project it up to here like this. Okay, so it will not be in this manner. Okay, so it will be here. So that, I mean, concept has to be clear. So since this pyramid is inclined like this, from the side also if we see, so this is B dash O, so this is BO, this is H. Okay, it is also inclined at an angle of that much. Okay, so when we see from top, we will see this point projected down. Okay, this point projected down. So that point you can trace it up to this point, and that point you can trace it like this up to this point. Okay, and then when you join it, you will get this plane. So this is the front view, this is the top view, and this is the side view from here. There is from this side if you see, all right, on from the front. So this is the side view. Okay, so those points you have to keep in mind. So this concept you keep in mind. Okay, so here, actually from here you have to project it like this. From here you have to project it like this. Okay, so we have the plane of intersection. Okay, front view, top view, and side view. So then we have a cylindrical 40 mm diameter, 60 mm height. All right, so cylindrical cylinder, so it is 40 mm diameter, 40 mm diameter and 60 mm height, and having its axis vertical and is cut by a section plane perpendicular to the VP. Okay, perpendicular to the VP, so it is perpendicular to the VP and inclined at 45 degree to the HP. So it is inclined at 45 degree to the HP. Here 45 degree to the HP, intersecting the axis. So intersecting the axis 32 mm above the base. So intersecting the axis 32 mm above the base. So that is also given. So first step is draw the top view. So you draw the top view. Second step is draw the front view of the cylinder. So draw the front view of the cylinder. So once that is done, now what you do, you draw the plane, intersecting plane. Now the plane, it is intersecting of the axis at 32 mm above the base. So this is 32 mm. This is 32 mm, this point of intersection. Okay, and it is inclined at 45 degree. So this plane you draw. So number one is top view, number two is front view of the cylinder, number three is plane of intersection. So once that is obtained, okay, so definitely in a cylinder, if you see from top also, you will see the entire section here as a circle only. Okay, so there is no problem in that. For a cylinder, if you see from the top, you will see the entire section as a circle only. So that is the plane of intersection here. Okay, but if you again you have to draw the side view. So thing is that you have to obtain this points, intersection points, and then you have to project it here, and ultimately from here also you will project it in this manner, and you will get this plane over here. So this is the view when you see from this side. Okay, so you will see a circle only in that case also. So in this case also you will see a circle. Since it is 45 degree, if the angle is different, then only you will get some different view here in case of the side view. In case of the top view, it will always be a circle. Okay, it will always be a circle. And this is the front view. This is the front view over here. And this plane over here, is the actual section of the solid, or the sectional view of the solid. So if you see directly, from the top, all right, normal to the plane, then you will see this view. So what are the steps? First step is draw the top view, second step is draw the front view, then you draw the intersection plane, then you project the points wherever is required, so either in this manner or this manner, and ultimately you will get the intersection points and you draw the intersection surface. Okay, in case of cylinder it is no problem because top view will always be, it will include the entire diameter. Now this is a cone. So we have a cone, so just like the square pyramid, here also we have an inclination here, like this. So in case we draw this projection over here, so we will get the projection like this. So it will be of lower diameter here. Okay, and this is the base of the cone. So just like the pyramid. Okay, so here also in the cone also we will observe this section of the solid, and this will be the intersection projection, and this is the intersection plane over here projected here. So yeah, this is what we get. So this is the top view. So first step is, again here also, first step, number one step, draw the top view of the cone. You draw the top view. Forget the intersection plane. First draw the cone top view. So cone top view first is drawn. Second step is get the front view of the cone. So get the front view of the cone. Third step is draw the intersection line. Now once you get the intersection line, so this is the intersection line over here. Okay, so this point you can project it directly on the diameter. Okay, and this point you can directly project it on the diameter, and similarly this will be the diameter of the circle, and ultimately it will be a circle. Okay, it will be a circle. So when the plane is parallel to the HP and perpendicular to the VP, so there is no problem while drawing a cone. While drawing a cone, there is no problem. But problem is when it is inclined. Okay, so we have a plane. So we have this plane which is inclined to the HP in this case, and it is perpendicular to the VP. Okay, it is perpendicular to the VP. So in that case, how to obtain that? So what we will do is, so the first step again, just as in the previous case, so the first step is to draw the top view. Okay, so we draw the top view. Then we draw the front view. So then what we do is we divide the cone. So we now then we draw the, suppose we draw the intersection plane. So now we have to get the points. We have to get these points and these points. Okay, how to get that? So to do that, what we do is we first divide the cone along its length into some sections. So we have divided the cone into, suppose, 3 sections. So then we obtain the diameter of these sections, just like the previous case, just like this case over here, just like this case. So we are just lowering the plane of intersection. Okay, so we will get an intersection plane here, and we will get an intersection plane here, and we will get an intersection plane here. So like this we will get some intersection plane. So that is what we are doing here. Okay, so we are getting some intersection lines, so some perpendicular planes, along some perpendicular planes. Then what we do, once these circles are drawn and these sections are made, so then we get these points. So C1, C1, C dash, B1 dash, B dash, A1 dash, A dash. So A1 dash, A dash, we drop it. So where this circle, this circle corresponding to this circle, we have these 2 points. Okay, similarly B dash, B1 dash will be corresponding to this circle. So we have this B1 and B dash points. Similarly, C dash and D dash is here, these 2 points, and we have D dash and D1 dash at the end. Okay, so this is the top view of the intersection plane. So top view of the intersection plane. Okay, and this is the actual view, the sectional view, all right, of the plane, like this. So this triangle over here, all right, triangular intersection plane over here, obviously, but this is what is our importance. Okay, thing is that we divide the cone into number of sections here. Number of sections here, we divide the cone, and we drop projectors, and we draw the circles. We draw the circles here. Once that is done, we obtain these points. So A dash, A1 dash, A dash, A1 dash, B dash, B1 dash, so B dash, B1 dash, C dash, C1 dash, C dash and C1 dash, right, D dash and D1 dash. So we have this cone or this triangular intersection plane. Okay, the concept is of this manner. Okay, we are lowering the intersection plane and we are getting various points of intersection. So here we have a plane, so it is inclined at a particular angle and it is intersecting a cone. Okay, and we have an ellipse, So here you see we have an ellipse. Okay, so thing is that how to draw that. So again, same manner here also. Okay, so same manner here also. Here the diameters are not shown. So thing is that we divide. Okay, so one section here, two section here, three section here. Okay, and this is another section. So dividing that, we draw circles. Okay, and then we drop the intersection points here. So we get two intersection points. Okay, we get two intersection points, and ultimately we draw the ellipse. And this is the side view. So if you see from this side, you will see this side view like this. So basic idea is, if I draw a circle here like this, perpendicular to the axis, so it will intersect at 2 points. So those 2 points we have to obtain. Okay, similarly, now if I draw a circle here at this level, so I will get 1 point and 2 points. So those 2 points I will get here. Okay, those are the 2 points. So those points we have to obtain. So the concept is similar to this. Okay, so this much is enough for the actually section of solids. All right, thing is that you have to get the idea. All right, so the idea you have to get up, so then only it will be easy, then it will be easy. So thing is that here you see, like here in the case of the pyramid, in the case of the square pyramid. So in the case of the square pyramid, so first of all we started out with the base, then we made the drawing of the or we made the projection of the front view, then obviously the side view. Now when we are intersecting it with a plane, so just like in case of cone, the other two sides are also inclined. So here D to O, you have to get the idea that D to O is also inclined. So when you see from the top, you will see 4 to D outside. So 4 to D, you will see outside. Okay, it is not intersecting. Similarly, 2 to D, you will see outside. So it is not intersecting. So 2 to D, you will see outside. So the plane is intersecting at these 2 points. Okay, so those 2 points can be directly projected down like this, and up to this point. Similarly projected down like this, up to this point. And we can get the, so this is one here, and we can get the plane of projection, intersection of the plane. So this is the top view. So if we see from the top, you will see this plane like this, the projection of the plane in this manner, in this fashion over here. And if you see from the side, so 4 and 2 dash you will see the here, 3 dash you will see here, and this is the two edges, and similarly 1 you will see here, and this is the edge. So ultimately we get these two planes here. Right, just as the similar to the that of the cone. Alright, that part you have to be very careful with. Alright, so that it is not gonna you do not make a mistake. Alright, so that is, if this edge had been straight, suppose had it been straight, so like this, it had been a square prism. Alright, so here you will not see this D, so it will be, within here, hidden behind this 4, and hidden behind this B will be hidden behind 2. But thing is that it is a pyramid. So when there is a pyramid, you will have this outer edge, which you will see in the from the top. Similarly, you will have this outer edge, which you will see from the top. So similarly, in case of cone also. Similarly, in case of cone also. So here, if you draw the projection of this circle here, so straight down we will drop it, and straight down we will drop it. So this will be the projection that we will get. And if you see from the top, you will see this edge from the top, and similarly you will see the edge from the top. Okay, so that is why, so in case of the square pyramid also, this part was visible from the top. Okay, this part of the square pyramid was visible from the top. So I'm just giving an analogy. All right, so analogy of the square pyramid and the cone, because it is inclined edges. So in that case only we have to keep in mind about this particular problem. All right, so what to do now if the plane is inclined? If the plane is inclined, what we do is we apply this concept. So we draw perpendicular planes at various levels. So we draw perpendicular planes at various levels, and we get these points. So if I draw a circle perpendicular plane, so I will get this point over here and this point over here. So there will be 2 points. So here B1 dash and B dash, suppose I get. So if I draw a circle here, so 1 point and 2 point. So here B1 dash and B dash. So this is the circle. So that is the basic concept of getting the points for an inclined plane in a cone. So similarly here also the same concept we will use. So we will draw circles like this, and we will get these points and this point. So they are the same level. We will get these points and these points. They are at the same level, and ultimately we will join these points which are the same level, and we will get this section. Okay, similarly here also, if we have to draw this side view, so similarly we will project it up, and from here we will project it up to this point. Okay, and then we will get the side view. So what they have done is they have projected the cone. So these projections which they have shown are basically the projections of the cone, all right, not of the intersection circle. So here you see in this drawing, so this is the cone, and these are all radial diameters or radius of the cones. All right, so those are projected up like this, and we have this line over. So we have this one here and like this. So we have this diameter. So basically this radius, is this edge, or this part of the surface over here. Okay, so that idea you have to culminate within yourself. Okay, that idea you have to culminate within yourself. So similarly here also, yeah, cylinder, it is very easy. So in case of this square pyramid or hexagonal pyramid or pentagonal pyramid, this particular concept you have to keep in mind, because the edges will be inclined. Okay, just like this one. Okay, so we see this part from the top. So this part from the top you see. Okay. And of course, in case of prisms, it is not very difficult. So here in this case of the square prism, so we have equally inclined, so easy steps. So first of all, you draw the top view, equally inclined, so the edges are equally inclined, the faces are equally inclined to the VP. Get the front view, get the intersection plane, and then you drop the projections here. So here 4 and 2 will be on the edge definitely, because had it been cone or prism, so it would have been like this, right? So that option we have to keep in mind, it would have been like that. But now since it is not a pyramid, it is a prism, so this f1 will be hidden behind 2 and this point will be hidden behind 4 1. So ultimately we will have this directly projected at this point and at this point, at the point 2. Alright, and the 3 point will be straight here. So 3 1, G1 will be hidden behind 3 1. Alright, so G1 will be hidden behind 3 1. So ultimately we have this plane of intersection. Okay, so that is the intersections of solids. So for various inclinations of planes, so thing is we have discussed two conditions. One is where the plane is perpendicular to the VP, parallel to the HP. Alright, so this is parallel to the VP, perpendicular to the HP. So this plane is parallel to the HP, perpendicular to the VP. Again, this plane, it is inclined to the VP but perpendicular to the HP. Okay, and this plane is inclined to the HP and it is perpendicular to the VP. So those are the only cases that is required to be discussed. So it has already been discussed in this class. So let us try some problems, and if there is any problem, then we will look into that. Okay. So the steps are shown. So go ahead with the steps. All right, knowing the steps, and it will be easy to draw. So I think we can stop here today. Okay, so we will stop here today.